We are talking about transformations of quadratic functions, and we want to describe transformations of quadratic functions and write transformations of quadratic functions. So in this example, we want to describe the transformation of the parent function to the function represented below. Then graph both functions. Let f of x represent the parent function. So here we have f of x, and we know that the parent function f of x is equal to x squared. So we can substitute points in and make sure that we have a good graph. So our vertex, we always want to start with 0, 1, and 2. So 0 squared is 0, so we get the ordered pair 0, 0. 1 squared is 1, so I go over 1, up 1. And 2 squared is 4, over 2, up 4. We can also go, we can also do 3, so we go over 3, up 9, because 3 squared is 9. And to find our other point, so we have 0, 0, 1, 1, 2, 4, and 3, 9. And to find our last point, we can use our line of symmetry, which in this case is just the y-axis. If I go up 1, over 1, I can go up 1, back 1. If I go up 4, over 2, I can go up 4, back 2. And I can go up 9 to the right 3. I can also go to the left 3. And so I can pick any one of those other points to finish filling out the table. And we get a parabola that looks like this. So we can just pick -3, 9. Next one that we have, this one was f of x. Next one that we have is g of x equals x minus 3 quantity squared. So we want to think about where the vertex is going to be. So the vertex for the parent function is at 0, 0. And then we want to look at the vertex for g of x. It doesn't move anywhere in the y direction. So we're still going to have 0 for the y portion of the coordinate. In this negative sign, although it looks like we should go to the left, remember that x is backwards. That's actually going to be 3 to the right. So that will be our vertex to the right. So 1, 2, 3. Now all of these points will be the same as they relate to the vertex. So from this vertex, let's not think about coordinates, let's just think about how to get to this point. So from this vertex, I went over 1, up 1. I'm going to do the same thing. From this vertex, I'm going to go over 1, up 1. So that new point is going to be 4, 1. From the original vertex in the parent function, if we go over 2, we go up 4. Well, that's going to be the same thing from this one. We're going to go over 2, up 4. Because we didn't change the shape of the parabola at all. All we did was we shifted it over. Now we're over at 5, 4. And if we go over 3, 3 squared is 9. So we're going to go over to 6. So the coordinate. And then the nice thing about a parabola is once we have one side figured out, then we have the other side figured out as well. So we can draw our axis of symmetry. And then we can plot the other half of the parabola. 1, 2, 1, 2. 1, 2, 3, 1, 2, 3. And so then we have a parabola that opens up And we can pick our last point, which is 2, 1. We have h of x equals 1/2 x plus 3 quantity squared minus 5. And so again, when I'm graphing this, I want to find out where my vertex is. Now this plus 3, we usually think, oh, plus 3, we're moving to the right. But plus 3, remember, because the original equation has a minus sign in it, means that we actually substituted in a negative 3. So our vertex is going to be negative 3, and then the y portion is straightforward, so negative 5. So that will be our vertex. So negative 3, 1, 2, 3, negative 5, 1, 2, 3, 4, 5. So that's where the vertex is. Now, previously in the parent function, our scale factor was 1, so we didn't change it at all. In the function g, our a value, our scale factor was also 1. So the proportion or the parabola had the same shape. But now we look at this one and our a value is 1/2. So that means we're still going to keep our right and left going by 1. But now when we go vertically, it's only going to be half as much. So if it was the parent function, we can sketch the points that would be for the parent if it was the same as the parent function. So go over 1, up 1. Over 2, up 4. Over 3, up 9. Okay, so if that was the parent function, if we just took the parent function without this 1/2, our graph would look and go like that. But now we got to take those values and we got to shrink them by 1/2. So we got to flatten this parabola out. So if we go over 1, up 1, instead of going over 1, up 1, we're going to go up half of that. So up half of 1 is 1/2. And instead of going over 2, up 4, we're going to go over 2, up 2, because 2 is half of 4. And instead of going over 3, up 9, we're going to go over 3, up 4.5. So those will be the coordinates there. So our coordinate will be negative 2, negative 4.5, and negative 1, negative 3. And then we have 0, negative 0.5. And then we can get, using our parabola here, we know that because it's got symmetry, we can graph the other side. So 1 over 2 over 3. And if we want to do 4, over 4 up 16 would normally be it. But now we just want to go up 8. So over 4, 5, 6, 7, 8, right there. And 1, 2, 3, 4, 1, 2, 3, 4. So we have a parabola that looks like that. And one more point we can pick negative 4, negative 4.5. So the other question says, describe the transformation of the parent function to the function represented below. So for this function g of x here, the translation 3 units to the right. Okay, so that's g of x. And then h of x, that had a few more transformations. So it had two translations. It had translation three units to the left, and 5 units down. And then it was also had a scale factor of 1/2. So that was h of x.